Hi everyone. Um, yeah, let's continue with the project today. I don't know. I don't feel any motivated to do it, but well, I initialized it. Let's try to finish that. Go to document, cd window project. Yeah, I think we will continue working with the window. So right now, I want to open to have a window that accept the test input. In the last one, we um we uh, download the TTF library in which we can take the font to render the test. Yep, and we initialize it. TTF init open font. I'm using the Satoshi regular.ttf. So yeah, let's see how it's go. Let's compile that. Yeah, so far we have this one. We're going to take the input in here, pretty neat. But I think I want to be able to turn this off, so I think I will make all of this into a if statement that we can turn it up by trigger a certain type of event in SDL app event. So yeah, I think SDL STL3 test input. I think I can use this one. Ah, this guy figured that out. Oh, keyboard input. Hit keyboard stay. No. Test input. I think I can watch this video. Let's see how it go. Sorry, let's skip that. What is he making? Coming soon. He wanted.
Once I'm done with that, the final fifth and sixth parameter is going to be the memory address of my window and the memory address of my brancher. And then I end my function with a semicolon. Looks like Java. Hey, what's this about? Honestly, this is like SDL3. I'm trying to display my text on my window like how usually users chat with NPCs in the games or like with other players in the game by typing stuff. Okay, this is C++. Oh, I understand. Okay, now once I'm done with that, once I'm done creating my window inventor, apparently in C++ we do gotta add an if statement to check if our function did not work properly because we give ourselves an error in C++. So I'm gonna do that. I'm gonna check if my window was not created properly or
Okay.
iOS 26. Let's make jailbreak. Okay, hiding Ducky, I appreciate you joining the stream. I'm great with Python, actually sounds pretty cool. Okay, hiding Beta John, is that how you pronounce your name? I appreciate you joining the stream as well.
Hmm.
Go ahead and do something. First,
Key input. Input test. I think I should watch the whole thing. My bad. Yeah, let's watch the whole thing.
I just haven't like heard that. That said, if my event type is key down, I'm firstly gonna do something. I'm gonna use the SDL underscore key codes structure. Let's go with something like SDL.
Oh, you use this one. Pressing detection. Yeah, I think when we press this one, it's going to trigger the this one right here. Start test input. How do we detect that we press something? Ah, I think we can use STL3 example. Yeah, I think we can have something that we can do. Input detection. Full game app demo. How do we scale it? Oh well. How do we detect the input? Escape tutorial hell. Yeah, if is keep press, right? I think there's a function for that. Joystick. Debugger test. Or oh well, sorry, I'm kind of slow today. Key press. Is this the right one? Update. Oh, I think we want to click that one. Test input right here. Can we have the someone set test input area? Oh, okay, this one. See a keyboard, window coordinate. Oh, right here? Really? Can it? Any example of this one? May play a window work near the cursor without coordinating test. Yeah, set the area used to type Unicode set input. Wow, really? Can I do it? Pool. Oh man, what does it do? Any example about this one? Kind of. Yeah, I'm kind of wonder if I can man. Is this possible? Yeah, no. Oh, I think I can do it. Let's try to figure it out. Yeah, let's try to figure out how to do it. Do we need to initialize that? Yeah, for this one, do we need it? Yeah, let's make a library first. Include SDL3 SDL keyboard.h. Should I make it? Yeah, is it? The offset of the cursor. what is the offset of the any example? Different on Android. Oh, right here. Documentation. Yay. Header file, STL keyboard. Yes. It's return a boolean. It's going to take the pointer to the window, the constant of the rectangle. I think I have it. This one. Yeah, this one right here. And the cursor. Wait, no. Any example? Do we have any example associated with this? Can we? Do we have example? What about this one?
You first.
Well, I think. How do we implement it?
Coding
Made
Hello everybody and welcome to your 10th SDL 2.0 tutorial, and in this tutorial we're going to be learning about our final event for now, and then we'll revisit events a bit later because I suspect you guys are pretty bored with events right now. So before we even start this tutorial, based on the game controller API controller last tutorial, there were 3 other functions that I missed out on that I think that you guys may find useful sometime along your SDL journey. It was the update function, which allows you to update the controller even if you're not in a loop. So if you just need to get like a single button press or something, there was getting the mapping name for the button and the axes. So if you want to create your own mappings, that would be a helpful tool for you. But that's all in the source code. So if you check GitHub on my website, you can get the source code for that. In this tutorial, we're gonna be learning about getting text input in SDL. It's useful if you want to have, say, a chat system where you want the user to input something in the game. It's a cool little feature to add. So it's sort of an addition to the key down event. So what we're going to do is we're going to create an empty string called text, and then below that we're going to say start text input, SDL underscore start text input. And that allows us to, it's self-explanatory, it allows us to start the text input, and obviously we have a stop text input. Now there's also a SDL set text input rect, but we haven't learned about SDL recs yet. So if I remember when I'm teaching about SDL recs, I'll show you how to display. It gives you sort of a rectangle on a rectangular area where you can actually input text. But even if I don't get to explain it, it's self-explanatory. Just ask for a rectangle and that's it. So the event is as follows. So we're going to say ev type SDL text input. And what we're going to do is, it should be else-if, sorry. So when we get text input, we're just going to say text plus equals ev.text.text, and that's just going to get our text. And what we're going to do is we're just going to use a system command. I know a lot of people complain about this stuff and saying that blah 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 blah, it's not safe, yada yada, it depends on your operating system. Yeah, I understand. But we're not going for safety and all that stuff. We're just trying to test this out in our program. So if you're on Windows, what you need to do is put CLS to clear the console window. If you're on a Unix-based system, so Mac or Linux, you're just gonna put clear to clear the terminal, window. And what we're gonna do is just say, okay, cout text. So what this is gonna do is that Every single time we get some new text, it's going to clear the console window, add the text, and then reread it to the console window, so it's going to look like we're continuously writing text. So let's run this program. We don't have an image because we don't need one. And if you check the console window, I'm going to say my is Peter Henry. So I meant to say my name. And as you can see, the text input, it takes in spaces and stuff like that. But it doesn't take enter or doesn't take backspace. So for right now, we're just going to be taking in backspace, and later on, if you want to do your own enter stuff and all that stuff, you can do that. So what we're going to do is we're going to say, okay, if the EV type is equal to that, or the EV type is equal to SDL button, or SDL button down, I believe it is. Sorry, it's SDL key down. Sorry, I'm really tired. It's almost 6 a.m. in the morning here. So we'll say it's SDL key down, and so what we're gonna do is we're gonna say, okay, if the key that we press, well, first of all, before we even check the key that we press, we're checking for two different events right now, so we want to make sure that we're actually using getting the right event. So we're gonna say if the event type is SDL key down, and the key we're getting is equal to SDLK backspace, and the length of the text is greater than 0, then we're gonna say text is equal to text substring 0 text.length -1, and that's just gonna erase the last letter from the end of the string. And then we're just going to say, okay, else if ev.type is equal to SDL text input, then we're going to add to the text, and we'll just put the clear screen at the top, and we'll have the CR at the bottom. Now the reason why we have to say we can't just put else, we have to put SDL text input, is that if we just put else, whenever we the backspace is considered a key, so it's just gonna say, okay, it's not this one, right? But you still enter the key, so it's gonna try to add the backspace to the text, which obviously doesn't. The ASCII values is a weird symbol, so that's not what we want. So we're gonna say, okay, if the type is text input, which the backspace, sorry, is not a part of text input, then add that to the text. So if you press anything, if you press any letter, any ASCII value or space, add that to the text. Otherwise, check for backspace and then whatever. So let's run this program to see what we get. So oops, I screwed up. Backspace, and then we can erase it, aka coding made easy, and voila, so we got something typed in the console window. But most likely not going to be typing the console window, but you can store it in the string and do whatever you need to do with it in your game or in your application. So anyways, that's it for this tutorial. Hope you enjoyed it. Don't forget to comment, rate, and subscribe, like my page on Facebook, and follow on Twitter. And don't forget to sign up on our website as well. So thanks, and bye for now.
Ready to level up your
Okay, guys, I think I know what to do. I just organized my thought a little bit. Will be my idea. So whenever I click this rectangle, it's going to open the input, and we can type in the words. Yeah, it's just that simple. So how do we do it? First of all, we need to have the set text input area. So I think if we use that function, it's going to and pass it in this rectangle. So and this rectangle will be the place it's going to take the input only. Yeah, so let's use this one. Fill rec. Wait, what does this one do? A pointer to the offset and the current cursor location. Oh wow. Yeah, let's use this one. So we have the test, right? So we use SDL set test input, set test input area, and we're going to take the window, right? Take the window, the rectangle, the pointer to the rectangle. Take the rec and the cursor. Take a no. Does it work? Let's try to compose that. No. Incompatible type. Oh, the address of the rectangle. Maybe like this. Maybe like this. No. Still error. How do we pass the rect? Yeah, let's view this rect. Oh, still rect. Should we make this? Ah. So how about we instead of like this, we will delete that and we make a should we make it correct like this? And we use this struct type there. Oh no, I think we can just do static SDL rec, and we can say rec equal null. So by this way we can access the rectangle. Yeah, maybe. Yeah, I need to learn all the basic again. Yep, that's not it. I think I don't know how to do it. We have to use a struct. How to access a struct and see. Oh man, I think type depth struct. See type depth. Oh man, I guess I'm lost again. Yeah, I don't have any basic in here. I guess I need to learn from the beginning. Oh, oh well. Yeah, it's my bad, sorry. How do I make a... SDR3 example, SDR3 tutorial. How do I use SDR rec like this one? Sorry guys. Oh well, I think it's not this one. Type struct SDL rec, something like this. And it's SY and width height SDL rec. Wait. How do I access it? Type def struct. Yeah, type def struct like this. Okay. So I think I can just have SDL rec, and you can call it rec like this. Oh, so it's just one warning. Okay. Oh my, oh wow, still under view rectangle. Oh no, I think I already have it. I think I don't need this one, right? Because yeah, let's just yeah, this one is good, right? So we just need to pass in this one. Yeah. Oh man, what have I done to myself? Why am I so bad at this? Use AppRec. Wait, SDL AppRec. Oh, I think it's only second in, right? I'm gonna take SDL rec. What do I do with this? Incompatible pointer. SDL rec. What is SDL in cursor? Three. Wait. How do I what is this one? What is the offset of the current cursor location? Window current. What is this one? Where do I find the documentation for this? Wait, how about I set input area key STL render. Anything else to make a test part? Cursor. What? Wait. Cursor. The offset. What is the offset of a current cursor location? Yeah, I think it's good to ask AI for this one because I cannot find anything. Yeah. Can you explain the cursor position? I think I I think it's follow this example. S 100. Oh, I think it's actually relatively to the S, right? So if S should be window width divided by 4, AM divided by 4 is 200, right? In cursor position equal it's to like 250, and we can use the if we use this initialize at the set input area and a window know the address of rec and the cursor position stl log failed to set input area %s new line stl get error. Yeah, to make sure that it won't work. Yeah, just to make sure that this won't work. Feel like just the address. No, sorry. Oh, feel like okay. Yeah, to refill rec and the feel rec. Oh, it's take the app rec. Okay. Oh, render field rec with an S. As an number of rectangle, just one. Okay. Wait. No. Another one. Field surface. This one. How about you this one? Because for the last one, it's only take the rectangle with the floating point, but we are using a rectangle with an integer, so I think we're gonna use this one. Field surface rec surface field rec in surface any surface for that? No. What? Hmm? I think they kind of changed that. Oh wait. I think they changed this to take the. I think I'm kind of rusty. Okay. I think I understand. Yeah, let's take abstract in here. Yeah, and STL rec rec2 abstract. Cool. Abstract. Cool. Let's do the same thing. Do the same thing. Equal abstract. Yeah. Which equal more. So I'm gonna set like that. Equal. And it's going to take a break. Yeah, something like this. Oh, okay. I guess that's not working. Rec dot s. Oh, wait. Rec dot s equal rec dot s. I think we'll explain this later. Rec dot y. Okay, let's try to retype that. F rec dot s equal f rec.y equal rec.s, f-rec.w equal f equal rec.w. So I think we essentially want this square, we want this the square that take the input will be the same as the no, it's the rectangle that take the input will be the same as the rectangle that we make in the beginning. Dot h equal break dot h. Yeah. So yeah, so clear test. Cool, so far so good. I think in the beginning let's just make a static well, let's see, because this thing never changed, right? It will be at the start of the program, so we will make it that way. F rec STL F rec. Yeah, we will make this way. So I think we can initialize it right here. Initialize it because we only, I think it's for more about the design choices. So yeah, yes, only initialize type def struct. Yeah, let's make a type def struct. No, I think it's only have that. So let's use static because I think SDL already make us a struct in the source code. So I think we don't need to do that again. SDL f rec SDL rec rec like this. So I think that is, if we finish everything, so we gonna initialize the initial position. Yes, about something like this. Copy. Yeah, let's initialize the overall one. So let's try to make a comment. Initialize the input rec by the rectangle. Initialize rectangle position. That will always appear at the start of the program. And this one is initialize the integer, the floating point, the integer rectangle that has the same coordinate as the rectangle, to use it as an input space for test. Yeah, so as a result we can do it like this way. we can do it this way. Yeah, it's always initialized like this. Initialize like this. So after that, we can use this one. Let's take the, let's go back the object. Okay, let's paste it here. Oh wow, the offset average. Okay, maybe I just use average dot s plus 50. Yeah. So as you change it, it will also change this one. Return STLF a failure. Yeah, the program will crash. If that's the case, so we don't need this one. Yeah, we don't need this one. This one will be the window color. Window color. Let's compose that. Test. Cool. So far so good. Okay, so what next? Start test input. How do we set test input area? Set the cursor position. So if how do we know that we click in the right position? Oh, sorry. Wow, that looks really fancy. Yeah, if we can we interact with that? No. By pusher. Yeah, I don't have any. If I think STL. Yeah, thank ChatGPT. STL test input. Start test input. Yeah, I think as long as we press in the position. Wait, how do we detect the key press? Detect the key press. Detect the mouse input. STL detect mouse input. STL3 mouse input. Mouse click. Mouse click. STL3 mouse click. Mouse button event. Oh, right here. Just I think when we click on this one, now click get mouse click in yeah, mouse event. Let's watch the video.
We transformed customer service with AI. What's going on, folks? It's Mike here, and welcome back to my SDL3 programming series. In today's episode, we're going to be talking about how to work with a mouse in SDL. So with that said, let's go ahead and dive in. So previously, we talked about how to handle keyboard input. And to the left, I have an example sort of building off of that. I removed all the get keyboard state, so if you want to check out keyboard stuff, make sure you check out the previous two videos. But the basic gist of it is figuring out what event type you have, and something like a key being pressed, and then we can query into more information about what specific key was being pressed, how many times it was clicked, and so on. So again, check that previous video out if you want information about that. But today I want to focus on working with the mouse. So we'll go ahead and start with working with events and various event types, and then explore a little bit more of the API. Now, the easiest way to get started for mouse actually is to just look at, I'm going to go to the API by category here. And I'm just going to search for mouse. There's a few different ways to get to this, but let's look at the mouse support here, and I'll get to the category mouse here. All right. And this will give me, if you scroll down, all of the mouse related functions. And you can see some of the ones I've clicked on and some of the structures and so on. But where I want to start here, so starting from the directions here.
Oh, I think category mouse, STL mouse, category mouse. So we can use here. Event mouse motion, button down, create cursor. Oh, I think, wow, yeah.
Talking about SDL events again, and doing things with just moving a mouse around and figuring out its motion. So again, if you're doing gestures or just trying to figure out how much you move the mouse up over a variety of, let's say, between two frames in a game here, so you can calculate some sort of distance, this is going to be your helpful event type that you want to track here. Okay, so with that said, let's click on SDL event mouse motion. It says, okay, refer to SDL event type here. Okay, got a bunch of types here. The easiest thing actually is just going to be I'm just going to go to SDL event here and just look at the structure again here. So again, how to navigate this union here is to look at mouse motion event here, which is going to have our mouse motion data. And I usually just copy it and then do Control F, and then it'll take me to the bottom down here. And again, this is the event type that I'm concerned with here, and the event.motion. Okay, so let's go ahead here. We'll go ahead and add to our else if event.type equals event mouse motion. And let's just go ahead and do a log here. And we'll log the actual motion that took place here. And this is going to be event.motion, and that's what gives us access to this struct here, SDL mouse motion event. And then within this here, we can figure out things like the X and Y position. Again, these are floating point values, which is really, really nice here. And we can actually see the relative motion in the X and the Y direction.
Mouse motion. Okay, go to mouse motion. Mouse motion event type. Yeah, I think mouse motion down, mouse motion. Oh, but mouse motion rest. I think we can use this to detect that we click. If that's the case, so data types, mouse button flag, mouse motion down. Category API. Oh wow. Micro enum function. Oh wow, that's a lot.
Let's go ahead and let's play around with a few of these just so we can see like sort of the distance that we moved here. So let's do we'll do this 2 times here. I'll just do X, Y, and then I'll put a comma there. And then again, this could be event.motion X, event.motion .y here. Okay, so simple as that. And let's make sure we get one of these working here. I'll compile it, and run it. And then now, as I move around, you can see my X and Y position. So again, the top left corner being 0, 0. And as I move to the right, the X position will increase. And as I move down, the Y position will increase that second value here. Okay, to my bottom right corner here, which is the maximum or the width and height of the window here. Okay.
This is GenSpark. It's like having a full stack.
All right, so let's look at those relative positions here. Some nice properties. So X relative and Y relative, just so you can see the difference in what those mean. So I'll recompile, rerun, and now you'll see as I move around, the X and the Y values are, much smaller, but they are negative sometimes, but it's telling me per the last time that I sort of queried where the position was, where was I? So if I move my mouse really fast, you'll see those values are sometimes larger because per the frame, my mouse skipped really fast, right? If I moved my mouse in a direction really fast. And again, that can be very useful if you're doing like a rotation in a game or something, or trying to figure out, like if you're literally in a game or mechanic, like flicking the mouse to do some sort of movement, the velocities, for instance, in the X and the Y direction. So you can use all this information to do interesting stuff with mouse motion here. Okay. So those are some of the interesting parts of mouse motion. Let's go ahead and start looking at how to detect mouse clicks. Okay, that's probably the next thing that we want to do here. So what I'm going to go ahead and do here is, let's just scroll up to the top again, pretend we don't know what we're doing. SDL event, and if I look through these events here, I'll find mouse button event. Okay, so mouse button events means, mouse clicks. So let's go ahead and do, again, Control F, and I'm looking for event I'll capture an event button rather, but these are the types of things I can do. And let's say we're concerned with just pressing the mouse down. So that's going to be our event type here. And then that'll give us the SDL mouse button event here. Okay, so one step at a time. Let's do our else if event.type equals mouse down here. And that'll give us the, just to show you the second part of the picture here, event.button then is how we access the union saying, hey, there was a button event, so now we want to treat this as whatever data is in that union SDL mouse button event. And then we could do some stuff like figure out clicks, for instance, how often this button was clicked. So let's go ahead and do that. Log, and let's do clicks. And this is going to give us some integer value here. Event dot.
Oh, okay. I think we can detect it. So I think works something like this. So if we click in this rectangle, it's going to check if my mouse is clicking if my mouse is inside of this rectangle. If it is, then it will count that we click into this, and it's going to start the test input. So do exactly like him. Let's use else if event type equal STL event mouse button down like this, and if let's use event motion motion
button
click
here. Okay, so let's go ahead and do that here.
event mouse button down. Yeah, let's do event mouse button down. Let's try to set it. So you have to read event mouse button. Down. Oh wow. How about this one? Starting point. Mainly use C++. I'm using C.
Move my mouse in. Now, I'm still capturing the motion events here, but if I stop and then just click my mouse, you'll see there.
Event button. Yeah, how about I use event mouse motion dot s equal greater than rec dot s rec rec. Yeah, let's go to check if this in this rectangle. Rec. Wait, no. Oh, this should be rec. It should be a regular rec. Sorry, I can do it back one. So it's gonna be easier to discriminate. Rec. Yeah. So this should be the normal rectangle. Loading point. This one is the integer. F rectangle. F. So this one the normal. Yeah. So this one's the normal. Let's use the frec. Frec and let's see. It should be for the S should be somewhere around here and here. So the width is multiplied by 2. 200 times 2 is 800. So it should be this one right here is 200 times 2 is 400. Yeah, 200 and 400. 200 400. Yeah, 800 by 4, 2 times 2 is 4. No, 200 400. This one is 600. Yeah, 600. frec.s and event mouse dot s less than frec dot s plus then 6 frec 600. I guess, and this picture is in the high, in this high, and if events mouse motion dot y is greater than 200, right? Wait, this one is 200. This one is 200. But 50 is, this one is around 250. This one is 200, greater than 200. F break dot y and event mouse motion y. Yeah. Event mouse motion dot y less than f break dot y plus 50 stl log. You can duplicate the chat, duplicate the test bot. Yeah, let's see it. Let's see it in action. If this one work or not. No, of course not. Mouse. Oh, my bad. I have to fix that one. Event motion. Oh, just motion. Oh, it's just motion. There's no mouse. Event motion. Only the motion. But what do we see the SDL event view rec? Ah, view rec. So it should be the app rectangle. Motion. I think there's no mouse. There's no mouse keyword in here. Event motion.s. Really? Did they fix that? Cool. Yeah, what if I click this one? Not work? Yeah, Mark, you click at the test bar. Wait, work. Oh, thank you, mom and dad. Thank you. You click the test bar. Okay. Okay, so far so good. If we click the test bar, right, then we're going to choose to start the test input. SDL start test input. Test input. Okay. So we're gonna initialize that. Let's see.
If I click really fast, you'll see that the clicks go up, and then it'll refresh down to not any notes.
Yeah. Dynamic test abstraction, test rendering. I think go to take the string. Update that. STL to read test input. We had a video. Dynamic keyboard. Keyboard input. Yeah, this one.
Text input.
Oh, no.
And what we're gonna do is, it should be else if, sorry. So when we get text input, we're just gonna say text plus equals ev dot text.
Okay, so we need a string. So we need a string that we can use. Okay, let's make it right here. Chart. How many work do we need to allocate for that? I think we can dynamically allocate the space. Dynamic allocate memory for string in C. Yeah, we can try this. It's a string. Create a dynamic. To create a dynamic array of string and see, we can use the concept of double point. I think we can use this one right here.
On a recent video, a viewer asked if we could make a video on how to dynamically allocate memory for an array of strings in C. So that's what we're going to do in this video. We're going to dynamically allocate memory for an array of strings. So if we wanted to dynamically allocate space for a single string on the heap, it would look something like this. We'd say car star string is equal to, and we could call malloc, and we would say size of car times length, where here we're pretending that length is the length of the character array that we want to create to store the string that we're going to store into it. And then size of car is the number of bytes that it takes to store a character. So basically we're going to allocate space for this many characters. And then string would be a pointer to that dynamically allocated block of memory on the heap.
Okay.
Now, in the case of an array of strings, we're basically taking this concept one step forward, where we're going to have not a pointer to a character, we're going to have a pointer to a pointer to a character. And we could call it strings.
Oh.
And what we're going to dynamically allocate space for initially is not some number of characters. We're going to dynamically allocate space for some number of pointers to characters. So really, we're going to dynamically allocate memory in two steps, basically. At first, what we're going to do is dynamically allocate enough space to store enough pointers to characters on the heap. Then in the second step, we're going to dynamically allocate enough space on the heap to store each individual character array for each individual string. So we'll go over it with an example. The first thing I'll do is include a couple libraries to help us. I'm going to include the string.h library because it has helpful functions like the string length function and string copy function that we can use.
Okay.
I'm also going to include the stdlib.h library because that has the malloc, calloc, and free functions that are used to dynamically allocate memory in C. So next I'll make a variable called total. And total is going to store the total number of strings that we're going to dynamically allocate space for.
Yes.
And I'll ask the user for that number of strings. So here we'll say printf enter number of strings, and we'll prompt the user to enter the number. And then we'll store the number they enter into total using scanf. And now we can allocate space for this number of pointers to characters. So we can say strings is equal to malloc total times size of car star. So what we're doing is allocating space for strings to point to this number of pointers to characters. So strings is going to have a pointer to some block of memory that's able to store this number of pointers to characters. And each one of these pointers to a character is going to be a pointer to our dynamically allocated character arrays that are going to store the actual string itself. So next what we're going to have to do is actually ask the user for each string. As we receive each string, we're going to dynamically allocate space for it. So we'll make a buffer to store each string that the user enters. So we'll say car buffer. And what we'll do is give buffer a very large size. Because it's really only temporary, we're just basically using it to receive the strings.
Oh, I think we cannot do it because in real time, so we have to need a buffer. So I guess we don't need to allocate that. Let's have let's call the function start test input window to open. STL start test input window. wait, if this one is fail. Yeah, if this one is fail, STL log couldn't start test input %s new line and STL get error. Yeah, get error. Can we pause the program here? If we cannot, I guess no. Need a buffer. Yeah, then we need a buffer to store the input buffer. Yeah, to store the input. How much is that? Like a really large amount. Let's define max input. Let's define the max input. Define math test input. Let's define like 1000. This input will large amount for the relative path. To the file, yeah, to the file. Math test input amount. Yeah, that's a math test input amount 1000, like that. And we go back to the example right here. It's going to take the input.
Just gonna get our text, and what we're gonna do is ev.type is
Okay. SDL event type start test input. So we can make an if event type equal SDL test input. Do we have this one? Test input. SDL test input. SDL to read test input. Test input event. Oh, SDL test input. So we can use SDL event test input, or I think he used key down. He used the key down. SDL key down in nanosecond. Oh, SDL key down. Wait. SDL 3 key down. So it's detecting that we are typing something. Typing something. event type equal STL event key down. You're pressing something. So we're pressing something, right? If we're pressing something, go to check again. If the keys, yeah, and if event type, so we check what key we are typing. STL event key down and key that backspace. I think for the example key code. Oh wait, yeah, let's use a key code. STL key code. Key code. He used the. Wait, I think in the example we have it. STL3 example right here. Go to this little game down here. Okay. Update player. Debug string. Player. Yeah, init. Create window. Here. Key. Event mouse. Down. Here. Right here. Event mouse down. Key code. Oh, he used key code. And event. What did he use? Key SM. Event key. SM. He used the key dot sm. Go to sm equal the code for the backspace. We want to delete that, right? Backspace. SDLK. Backspace. You press the backspace, and the test is, and this test is not equal. Let's see. Input buffer dot length. Length of string. Wait, let me just see. Length of string in C. Oh, strlen. I'll use that function. Okay, this is not C++, so I gotta be careful. And it's not Java. Length input buffer less greater than 0. Yeah, yes. If that's the case, then we remove it. test equal, wait, input buffer equal, let's see, remove one word from a string in C, from a string, delete a current. Okay. Remove our current substring.
In this video, we're going to write a function in C to delete all occurrences of a substring, and it has no return all occurrences of it. Forward the remaining characters by 3 and replace the remaining characters in the string, and we'll say strlen string. So we're going to use the
in the C++, he used the substring. Is there a substring? Oh wait, no. Delete work string array. String. Big. So I think memu efficient. Oh. Len string work. Shift character to the left. Okay, let's make a new function. Yeah, we want to void delete work. So take the string str. Let's use charge work in length equal str length str. Delete specific. I think it should make our function memu. Wait, what is memu? Let me see. Yeah, memu. stdio include stdio std.h memu copy. Oh, so this is the string p the length of the work, remove beautiful. Oh, the length of the work, just be 1. We don't only need delete 1. Just be string str work, find the work position, find the in the string that need to be removed if p plus len plus 1. Oh. String length shift character to the left, no terminator. Oh, what delete work? Okay, delete work, input buffer plus 1. Wait for this one. What is the how do I find the last word? Of string in C. Ah. Oh. So they're going to loop through the string. Okay. We need to have a function jar get select work. So get a string. If length of the work okay, I think I loop to the work. If the length is not equal to 0, stl log cannot get empty string. I don't know. less than length minus 1. This one. Okay, that's way too late. Let's work. Wait, can we go to the specific index of the string? Equal str minus 1. Oh. Oh wow, this is really valid. Yeah, delete the work. Backspace. Key down. Yeah, test input. Key down. Okay, okay, else if event type equal stl event test input input buffer equal test. Does it really work? No. Oh, my bad. No. Wait, does it really work? Oh, wait, clear. No, still not. man. No, I think we don't need this one. If we want to get the last word, we just need to input buffer str len input buffer, and we just subtract 1 for the node terminator, and make sure I get the last word. Cool, file error. Event key, init key, oh wow. Use a key go. Oh wait, I think I should watch this one.
With
str3 key input. Key press. Yeah, more key input. This one.
Hey, what's going on, folks? It's Mike here, and welcome back. It'll be valid, this pointer that I get back, for the whole duration of the program, right? So this is something that I could just do here.
Key. What?
Again, it looks like this is a array of bools. So let's just do keys or something like that. And the pointer itself is what I should say will not change here. So get keyboard. Oops, let me make sure I do this right. Keyboard state. And then for the parameter here, if it's non-null, I receive the length of the returned array here. All right. Oops. Let's be very specific. Good. Now, how do the scan? Okay. I called this keys. The pointer here. It's you want to check some if here, and I might have to hunt a little. E F G H. Oh, that should. Okay, so I didn't have to guess for what was that? The letter L. Well, we'll just pick one here. So scan code L here. Okay, that's 15. Okay, for whatever reason. Let's see if that was.
Key go. Okay. Go sm equal event key dot key event key dot key. Yeah, something like this. What? Key. Okay. See, how do I bend the string? Bend to a string C. Connect the string. Cat. Input buffer. Key. Oh wow. Oh yeah, with 2 error. They work. Uh, any character. Oh. Okay. C. Um, okay. Okay. Add chart, input buffer, event, key. Did he win that? Yeah, let's use SDL log. Same as input buffer. Yeah. Okay. Wait. What? Oh wow, I think it's late. Bye guys. Yeah, well, I think I keep up. I think I won't do it anymore. Yeah, bye. Okay guys, well, it's not like I give up or something. Yeah, but I kinda desperate, so I chat GPT and it give me the structure. It is much more convenient. So I'm going to type it. Switch event type. Oh, it's really similar to SDL3. Oh, okay, understandable. Case SDL event quit. Oops, my bad. Case mouse button. Okay, I figured out. I guess I'm going to do it tomorrow. Yeah, it's really late. Bye.